Hey, welcome back. In this lesson, we're going to use angles of elevation and depression to solve problems. So what we need to understand here is an angle of elevation. So if you're this person standing here looking at your friend up on the hill there, if you look straight ahead, so this would be the line straight ahead. That this line is parallel with the ground, right? The number of degrees that you would turn your eyes up to spot the person is called the angle of elevation. Okay? And if you're the person standing up here and you're looking straight ahead, again, this is parallel with the ground or with the horizon. If you turn your eyes and look down, this is called the angle of depression. Now, one thing you need to understand with these, if you look at the dotted lines, these are parallel lines. And if you remember back from geometry days, when you have a transversal that it crosses parallel lines, these angles here and here are called alternate interior, and they are congruent. So if this is 30 degrees, this would be 30 degrees. So angle of elevation and angle of depression. All right, so here's a problem. Suppose you stand 53 feet from a wind turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. So the hub of the turbine means the top right here. So the angle of elevation, you're looking straight ahead. That's right here. The number of degrees that you're looking up is 56.5 degrees. Your eye level is 5.5 above the ground. So that means from your eyes to the ground is 5.5. So the distance from here to here is 5.5 feet. Approximately how tall is the turbine from the ground up to the hub? So what we have to do is we're going to use trig to find x. And then once we find x, we'll add it to 5.5. So let's start out by labeling our triangle. So here's our angle. This is opposite. That's the hypotenuse. This is the adjacent. Opposite and adjacent is tangent. So the tangent of 56.5 equals the opposite over the adjacent. And we will cross multiply. So we get 53 times the tangent of 56.5. So x equals 53 tangent 56.5. And that is 80.1. So this is 80.1. So how tall is the hub? It is 80.1 plus 5.5. So that would be 85.6 feet. That would be your answer. All right, here's another problem. You sight a rock climber on a cliff at a 32 degree angle of elevation. Your eye level is 6 feet above the ground, and you are 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So we have to draw a picture. So first, here's you. All right. And you sight a rock climber on a cliff. So here's the cliff, and then here's the rock climber right here. Okay. Your eye level is 6 feet above the ground. So this is if you look straight ahead, and this is the angle that you're looking up. So we'll call that 32 degrees, the angle of elevation. And your eye level from here to here is 6. So I'm going to put a 6 right here, 6 feet. Let's see, you are 1,000 feet from the base of the cliff. So from here to here is 1,000. And what is the approximate height of the rock climber? So we'll put an X right here, and we're going to find out what this length is and then add 6 to it. So again, we'll label opposite. This is a 90 degree angle. This is the adjacent. So that's a tangent function again. So the tangent of 32 equals x over 1,000. So we'll write x equals 1,000 times the tangent of 32. Which is 624.9 feet. And then you would add 6 to get your final answer. So plus 6, so that would be 630.9 feet high. All right, here's another problem. Airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is 3 kilometers. What is the airplane's horizontal distance from the raft? Okay, so you have an airplane pilot. All right, and this is if he was looking straight ahead. Okay, he sights a life raft at a 26-degree angle of depression. So if he looks down, here's a little life raft. This is 26 degrees. The airplane's altitude is 3 kilometers. So that means the perpendicular distance to the ground, that's the altitude, how high up it's flying, is 3 kilometers. What is the airplane's horizontal distance? So if you're measuring from right here to how far it is, that's the horizontal distance to the raft. So we're going to call this a D. Now, if it was the type of problem that said if it was the airplane was going to fly straight down, how far would it be flying? It would be talking about this length right here. But it's asking for the horizontal distance. So that's from here to here. All right, so now we'll label. Okay, so this is the angle, and you'll notice I don't have numbers here. You have some options here, but what I usually do is I use the alternate interior angle. So these are parallel, so this would be 26. Or you could also do it this way. Make a rectangle, so this would be 3 and this would be D, and work with a triangle up here. Either way. So let's see, if this is our angle, this is the opposite. This again happens to be the adjacent. You're not always going to use trig on these, but in these particular examples you do. So we write tangent of 26 equals 3 over D, and we cross multiply. 3 equals D times the tangent of 26. So to get D by itself, divide by tangent 26. So 3 divided by tangent 26, and you get 6.2 about. And it would be 6.2 kilometers. All right, so you are going to be working on a worksheet with word problems, and I'm going to go through a few of these and just help you set up the pictures here. So number 1, a boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? Okay, now in this problem, it doesn't say anything about the eye level of the boy or anything like that. So if it doesn't say that, you kind of ignore that fact. So he lets out a string. Let's see, he lets out 300 feet of string. So we know that's how long the string is. Here's the kite up here. And that makes a 38 degree angle with the ground. Assuming that the string is straight, how high above the ground is a kite? So that would be the perpendicular distance to the ground. So that's what you're looking for. Let's see here. An airplane climbs at an angle of 13 degrees with the ground. Okay, so this is 13 degrees. The airplane's climbing. Find the ground distance it's traveled when it has attained an altitude of 9,000. So that means that the distance from the plane, the perpendicular distance to the ground, is 9,000, and we want to find the ground distance. All right, I'm going to look here and see if there's something different here. From the top of a tower, the angle of depression to a stake on the ground is 60 degrees. The top of the tower is 80 feet above the ground. Okay, so here is the tower. It's 80 feet. It says angle of depression. So if you're looking straight ahead, that's like this line, but you're going to be looking down. Here's the stake on the ground. So this is the angle. It's 60. And how far from the stake is the stake from the foot of the tower? So here's the foot of the tower, here's the stake. We want to find that distance. Now if this is 60, this is 60. And now you can solve. A tree casts a shadow 21 meters long. Okay, so here's your tree. It casts the shadow, so the sun must be up here somewhere. All right, so the shadow is 21 meters long. The angle of elevation of the sun is 51. So if you're here, the angle up to the sun is 21 degrees. What is the height of the tree? There you go. All right, Elise is standing on top of a 50-foot building and sees her friend Molly. If Molly's 30 feet from the base of the building, what is the angle of depression from Elise to Molly? Elise's eye height is 45 feet. So here's Elise, and she's standing on top of a 50-foot building. And this gives us an eye height. So from here, we're trying to find that angle. So this is 4.5 right here. And her friend is over here, and she is looking down at her friend. Okay, so we want to figure out what's the angle of depression. Molly is 30 feet from the base of the building. So here's Molly over here. This isn't quite in the right proportion, I can tell. And we want to find this angle, which is the same as this one. So this entire length is 54.5. And so that's your opposite, and here's your adjacent. Fix that. So this length is 54.5. There we go. And let's cross out that problem. And let's see. Just checking to see if there's some that I think you might have some questions with. The library needs to build an access ramp for wheelchairs. The main entrance to the library is 8 feet above the sidewalk level. So they want to build a ramp that's 8 feet above. If the architect designs the slope of the ramp in such a way that the angle of elevation is 5 degrees, how long must the access ramp be? So that's going to be the length of the actual ramp, so that will be X right here. All right, so if you work on these, if you have questions, feel free to text me or give me an email or call me, and I'll be happy to help. I'll also be helping you with these during the Zoom session. Thanks for watching.